And again, thanks for your time. Appreciate it.
I appreciate it. Thank you, everyone.
So thanks, Ryan, for your presentation, and thanks, Andrew, for putting this all together. This is really interesting and certainly a topic of hot conversation for the year to come. And with that, I will invite Susan to come back.
Yep.
There we go. I'll invite Susan to come back, and we have our keynote presentation with Jamie Austin and with Simon, yes.
Yeah.
To talk about what happened in Abbotsford, BC. So Susan, over to you.
So very pleased to have two co-presenters with us today, Jamie Austin and Simon Horsley. Jamie is the Director of Operations at the City of Abbotsford in British Columbia. If people have forgotten where that is. And he began his career in 2001 in Ontario, and now is the Director of Utilities for the City of Abbotsford, and also holds a Level 2 Operator Certificate in water treatment, water distribution, and wastewater collection. And Simon Horsley is the Stantec's water quality lead for Canada and the US, with over 17 years of experience in evaluating and optimizing water treatment plants and distribution systems. He's also past chair of the OWWA Treatment Committee. And with that, I will welcome Jamie and Simon.
Okay, thank you very much. Thanks for the introduction there. So I'm Jamie Austin. I'm here in Abbotsford. It is 9 o'clock in the morning, so I'm just finishing breakfast, and I guess you guys are thinking of lunch. With me, I've got Simon Horsley from Stantec. He and Abbotsford pretty much were partners in taking on this flood event. So we've been asked to do a presentation for you, and we're very happy to do so. So I'll just let Simon get us going here.
Yeah, is that showing okay?
Yeah, you just gotta punch it into presentation mode, and I think we're good to go.
Here we are.
So, okay, so once again, thanks for having us. We're here to talk about the flooding of the Abbotsford Sumas Prairie and how we got the water distribution system back up and running. So a little background, what you're looking at here, this is taken by me from a helicopter on the morning of November 16th. So that was a Tuesday. Normally, what you see here would be lush green farming country, and you can clearly see something's wrong with this picture. Just to give you a little background, for those of you who have been out here, you can kind of make out a highway that kind of cuts through by a barn to the far left side of the screen, starts to bend around where the word flood starts, and off it goes up to Chilliwack. That's actually Highway 1. So that gives you a bit of an idea of the extent of the flooding and sort of the impacts it had on us out here. So I'll get Simon to go ahead to the next slide. This is the agenda. So for the presentation, I'm going to talk about the Sumas Prairie, some of the nuances of it, and how it interacts with the Nooksack River in Washington State. Talk about the flood event and from an operations perspective, how we initially responded to some things. Following that, this is where Simon and the gang came in. We started to come up with a reinstatement plan. The next step was to figure out how to implement that plan. And once everything was kind of back and running as normal, we, there's some conclusions in future planning. And then to wrap up the presentation, we will go to some question and answers. So that being said, we'll show you the Sumas Prairie here. So this is a shot of Abbotsford. So we're a population of about 150,000 people. That makes us, I think, the 6th largest in BC. As far as land area goes, though, we are the largest in British Columbia. So we're bound to the north by the Fraser River. On the other side of the Fraser River is District of Mission. To the south is actually Washington State. So we actually border with Sumas, Washington. What you're seeing here is a shot of our GIS system. This is our entire water system. So we have our supply system, transmission mains, It's about 1,000 kilometers collectively. You can see how most of it focuses on that central core. It's almost like a donut. That's where, for all intents and purposes, that's where the city of Abbotsford lies. Everything surrounding it is primarily agricultural land with some mountain ranges cutting through as well. So next little tap here from Simon. This will bring us into the Sumas Prairie. So this is a single pressure zone. It serves approximately 700 connections. It's relatively flat. It's pretty much all farming area. Historically, something called the Sumas Lake used to be here. So it was situated in sort of the eastern north side of it. So although the area is primarily flat, there is a kind of recessed area in that east side, which everyone refers to as lake bottom. So it is significantly lower than the rest of the prairie. Sort of separating lake bottom from the west side, where everything's a little more flat and there's a bit of a gravity draw down to the Fraser River, there's a dike. And the intent of that dike is to, when there is flooding events, to keep water out of lake bottom, because once it's in there, the lake starts to basically reestablish itself. To the west of that dike, water will actually flow down the Sumas River naturally out into the Fraser River. So that's a bit of the background of the area we're going to focus on today. So I wanted to head off to the next slide here. A little more, so the Nooksack and the Sumas River. So what I've highlighted first here is Mount Baker. So I can see this mountain from my deck. It's quite awe-inspiring. It's a thing of beauty to see, but it does drain a lot of water. There's snow up there all the time, and it's not unusual for this thing to let water down during the freshet, for example, in the spring, or if there's lots of rain. You can see the three arms there of the Nooksack. So there's the upper, middle, and lower arms. They basically drain Mount Baker, rainfall, it all catches in there, and it all gathers into one main section, Nooksack River proper, which passes through Cedarville up to Everson, Linden, down to Ferndale, and then ultimately out into Bellingham Bay. So for the most part, that's how things flow from Mount Baker, but there is another little river in here, which is known as the Sumas River. So it's the only river in the area that actually flows from the States into Canada. Most of our drainage actually drops either into the Fraser, or some of it, there's the odd one that runs actually down in the States. So for the most part, the Sumas River always has some level of water running through it, not an awful lot. And you can see quite clearly the two are separated, the Nooksack and the Sumas River. But Simon wants to click again, some more detail as we hone in here. You can see the town of Everson. You can see Highway 9 there going through the town of Nooksack. Nooksack River, as I pointed out earlier, stays kind of to the west of Everson. And right where that Nooksack Elementary School is, you can see some kind of meandering river there. That's actually the Sumas River. So there is a physical separation. Normally, these two things drain, at their own rates, one not impacting the other. However, probably since the glaciers were moving through here 8,000 years ago, it's not uncommon for the Nooksack River, especially during freshet, when we have the spring meltdown, for the Nooksack River to become overwhelmed. And right at the town of Everson, it will actually jump the banks of the Nooksack, it'll spill over Highway 9, and it will find its way out through Sumas River. So that's how the two interact with one another. And I've been out in BC now from Ontario for about 4 years, and I think this thing has jumped its banks probably 3 times. So it's not that uncommon. However, the flood event that we experienced is very uncommon. So as an operation, we're always watching weather, rain. Out here, if we get a forecast of 75 millimeters, the hair on the back of our neck starts to stand up. 3 inches, that's something to be concerned about. When we saw this forecast roll, and it said 100 to 150, and typically they seem to overestimate, I find here, and back off as the event rolls in, but they're pretty firm saying it would be 100 to 150. So we knew, there was significant water coming. I don't think we really figured it would be as large as it ended up being. ultimately at Abbotsford Airport, they recorded almost 180 millimeters of rain across this event. So, if you look at the bottom end, we almost doubled what was being forecasted. So the rain started on the 13th, and by the 14th, this is Sunday. So Saturday, rained all Sunday. By 5 p.m. on the Sunday, we had a notice that the Nooksack River had spilled into Everson. And the following day by 5 a.m., this is what we found on the border. So looks like a lot of water. It is a lot of water. So what we're looking at here, where this truck is parked, that's called Boundary Road. To the left, those blueberry fields, that's Abbotsford. The ditch to the right, that's actually Washington State. So you can see this water, we basically had a river coming across from Washington State into Abbotsford. As I said, it's happened only a couple times and just a little bit of water, but this went on for, if I recall, I think it was about 3 or 4 days. We had water continually coming through to us. So, I mean, the rain stopped on the 15th, but by the 18th, 19th, we still had water flooding in, beautiful clear skies, and yet we had tons of water literally pouring into us. So going on to the next slide. This is what everything looked like on the 17th. So normally this whole thing would just be a sea of green, farms kind of producing what they need to. A couple kind of highlights here. So the red kind of pinkish line there, that's Highway 1, that's Trans-Canada. So you can see it was underwater in several locations. Running up the middle there, that yellow line, that's the dike I spoke of earlier that separates the east from the west side. And kind of where you see Campbell Road, Dixon Road, number 4, you can see, we call it lake bottom, and that is why. That is where Sumas Lake used to be until about the 1920s. The Sumas Canal, the blue line, was dropped into the bottom of the lake, and that black dot up at the top, that's where Barrowtown Pump Station is. So Barrowtown will normally, if there's a rain event, water always wants to go back into lake bottom, but Barrowtown will draw water through the canal, pump it straight out into the Fraser River. And on the flip side, on the other side of the dike, we have the Sumas River, which will naturally drain with gravity and find its way out to the Fraser as well. But as you can see, the dikes did not hold. So there's a couple red dots in there. We've got a small one down to the bottom and kind of a larger one up near the top. Those things they popped on the 16th about, and the large one there, the one to the north, basically lake bottom was recreated because of that dike failure. So that kind of gives you the background of what was going on, how things would interact with one another. And if we run on to the next slide here, from an operations perspective, what were we doing? So Sumas Prairie, that distribution system, we ensured we could have it isolated through one control valve. So you'll see the Vi-Road ACV automatic control valve. It pops up periodically through this presentation. It was the one way of telling how much water was coming in. We have a flow meter there. So, if things were starting to go sideways with pressure or flow, we at least had a way to tell what was going on in the zone. And so we were very fortunate to have one feed in, which actually had a meter on it. That certainly did help us. So the morning of the 16th, I showed you that picture at the start. That was me in a helicopter at 9 a.m. By the time we got back down to the ground at noon, literally the dikes breached, and that's where that title for this presentation came from. You can't sometimes fathom that things could get any worse, and then someone tells you that the dikes have popped and things did get worse. So within a couple hours of the dikes going, by early afternoon, we noticed our 2 reservoirs out there in Sumas Prairie started to tank, and it didn't matter how much water we put through those reservoirs were losing fast. So we knew we had main breaks out there and we could not maintain pressure. So by 9 p.m., we had put a notice out to the public just saying, if you're out there, you're going to lose pressure. We can't guarantee you have any water. And by this time, evacuation notices were issued to most of the prairies. The very next day, we went out and started hunting for main breaks. We did find one, and we felt, pretty good about ourselves. We had isolated a break, and we were waiting to see for the system, let's see some recovery, let's see the reservoir start to come back. Unfortunately, they didn't though. So that told us that there was more than one main break out there. That took us to the following day, November 18th. This is now the Thursday. And we had issued a boil water advisory for the prairie. Keep in mind, again, an evacuation order was in place for everybody. And then within, I think about 5-6 days, we had upped that to a do not use advisory. At this point, we knew, there's too much surface water out there. Lake bottom was completely full. The lake had reinstated itself. There were some houses with, 10, 12 feet of water coming inside of them. And it was at that point, we started talking on the 17th, even once we found that that main break was not the cause of our problems. We knew we had bigger issues, and this is going to be a long-term project. For those of you who've been involved with boil water advisories or do not use, or water advisories, typically you try to get these things wrapped up within 3 to 5 days. You isolate things, you test, you get 2 rounds, notices go out, and you're back. But we knew we had longer standing issues coming up. Hence November 19th, had somebody hop on the phone and say, hey, Simon, you're busy right now for the next little while. So, and this is the cut over to Simon. So he got a call on the 19th, and lo and behold, he's now working for the city of Abbotsford. So over to you, Simon.
Sharing. Yeah, that was some phone call. So my background's all water quality related, chemistry related, that type of thing. So that's the lens that I started to look at this thing, an entire pressure zone under 12 feet of water, and what's been on with that distribution system. Before I came to Canada, I worked with Scottish Water. I worked in operational response there, and we had things like we had petroleum contamination of a system. We had a sampler roll a van into our impounding reservoir. We had bloodworms. We had all kinds of stuff that I'd dealt with. I'd never dealt with anything like this. This was a whole zone depressurized. And so when we started chatting with the city, with Jamie and his team, what's out there? And it's okay, there's a lot of agriculture out there. So we start thinking, okay, we've got slurry and manure storage out there, and all of the kind of biological concerns that might go with that in the event of ingress. And we might have, these are remote locations. We might have diesel for backup generators or for primary generators on these facilities. Could we be looking at diesel fractions, petroleum fractions? We knew through conversations with Jamie that they were losing a lot of water. So we were pretty sure we had some substantial main breaks, not the usual more minor sort of spring a leak type breaks, but real breaks in the mains. And so we were certainly contemplating potential for ingress and trying to think through all of the potential contaminants, which was everything out there. So we had to take all of the thoughts and actions that we could undertake, and we had to boil this down to a practical, step-by-step sort of stage-gated plan where we could navigate our way back to bringing the system back online. A big part of the project in general was there was nobody that had all the answers here. The city didn't have all the answers. I didn't have all the answers. We went out to industry and said, we need some experts on various different aspects here to come in and help us out. And so you'll see throughout, this was a very collaborative approach. All of us pulled on our networks. And I think it's fair to say that everybody got just tremendous support wherever we looked for that support. So I'll try and name drop when I can the support that we benefited from. In general, this is what the plan looks like, and then we're going to kind of walk through the various stages in a little more detail. But step one was just to get pressure back. I mean, Jamie's crews was still trying to understand the scale of the breaks. We'll take a look at a couple of images in a moment. But they knew, as Jamie mentioned, this is one pressure zone with one point of entry that has a flow meter. So we know how much water normally goes to that zone. And therefore we knew that the amount of flow that was going in now and failing to fill the reservoirs meant we were losing a lot of water out there. So we had some fairly substantial breaks. So restoring system pressure was number one. We can't do anything without that. Number two, with the system having gone, if we're able to isolate these breaks, what does that network look like? This has the potential to be a fairly serious ingress event. So how do you begin to bring back a network that's been compromised that way? Phase three, this is highlighted because I'm going to be spending a bit of time on this in a moment. Phase three was, we ultimately, Jamie and his team ultimately identified that most of the big breaks were within one focused area. And they were able to kind of ring fence that area and isolate that area. And we called that the isolation zone. And so even when we got the rest of the system back, this isolation zone would have to be brought back kind of piecemeal. And how do we go about doing that, given that those sections of Maine could be pretty messy, and we've now got this, nice disinfected and live network. And then finally, how do we get back to just normal service? So there was lots of collaboration between us, Stantec, the city, various external experts, Fraser Health, and of course, at the core of it, we were all very conscious that there were people who were looking to come back, and having potable water would be a big part of that. So I don't know if you can see to the right here, this is a water main to nowhere. This is the type of situation that Jamie's crews were starting to identify and realize. We had fully open pipes under a few feet of static head. And again, so, they're trying to keep this system pressurized. So hopefully that, the ingress stays out, but we never like pressure to be below about 20 PSI. Just for the purposes of maintaining pressure and keeping stuff out. And of course, we had compromised pressure all over the place. So phase one was the most essential first step, was Jamie and his crews just painfully, by a process of elimination, turning valves, monitoring pressure, going around, we were able to basically reach out to the local community of leak detection specialists, and some of them were able to help. They had guys out in boats, they had people everywhere trying to figure out where these leaks were. And as we said, eventually managed to figure out the majority, as it happens, were within one focused area. They were able to ring fence, but even then, a lot of other leaks to be found. We knew we would know when the number of leaks was coming under control, because those tanks would start to fill. We're pumping water in via that valve. And the idea is that valve is supposed to fill those tanks. If it can't fill it, it's just because we're leaking so much water. So when that comes under control, those tanks would start to fill. So that was our indicator. And right away, Jamie's going to come back and talk a little bit about the sampling and how that played into opening things up a little later in the presentation. But from the get-go, we were trying to come up with that sampling plan and get monitoring. And that sampling plan didn't look like a water system sampling plan. It looked like a source water characterization sampling plan, looking for everything from pesticides to organic, diesel fractions, polyaromatic hydrocarbons, everything we could think of. We did a complete sample suite because we wanted to know what we were up against. So this was bubbling along in the background. I want to talk about disinfecting this network. This was an interesting challenge. We didn't know what sort of, having brought the system back under pressurization, what's been introduced to the system, and what kind of volumes and pockets of water are in there that we don't want. So here's the things we had to think about. This is a chloraminated system. So as most of you will know, we keep our drinking water disinfected either by adding a little bit of residual disinfectant, either free chlorine or chloramine. Chloramine has some benefits, but it's a fairly weak disinfectant. It's a decent sentinel to let us know if we see total chlorines dip. With a chloraminated system, that says we've got some issue we need to look at, so it does well there. It's good for long-term managing biofilm. It's good for various things. It's a poor primary disinfectant. In other words, if there's an ingress event of something that needs inactivated, chloramine's not very good at that. Chlorine is. And so we wanted, as we got talking about it, we're like, what do we want to achieve here? Number one, we want to affect a complete displacement of all the volume in that system. Everything that's in there, we want it out. We want to start fresh. Number two, we want those walls, those pipe walls, to experience a stronger disinfectant, like chlorine. So we had to flip this system, which right now all we have is this bivalve that brings all this chloraminated water in. We got to flip this over to chlorine. And how do you go about doing that? I've converted various systems back and forth for different reasons over the years. So we've done this before, but I don't think ever in quite such a hurry. So the way you convert chloramines to free chlorine is kind of by adding just lots of chlorine, but there's a bit of a nuance to that, which I'll just come to here. So it's a very brief one slide, Bill Nye the Science Guy moment. But if you start off with a glass, if I was to go to the city today, city of Abbotsford, pour a glass of water, or indeed Ottawa, and pour a glass of water, I'd have a glass full of chloramines, that disinfectant. If I want to take that glass and convert it to chlorine, I basically have to take a dropper of chlorine, like liquid chlorine bleach, and dropper it in. But what does not happen is we just nicely convert. What happens is, for various funny chemistry, known as breakpoint chemistry, it goes through this strange cycle where the chlorine goes up, still chloramines, the whole thing collapses to almost no disinfectant residual at all, as all of the ammonia gets oxidized to nitrogen gas in this kind of quick moment. And then we reestablish chlorine. Why do I tell you that? Only because it makes it really hard to know what's going on when you've got water shooting past this valve, and we're looking to add chlorine to that. For about this reaction, this classic breakpoint curve that you see here, it takes about 20 to 30 minutes from when you add the chlorine to get to the other end, and it goes through this process. So any monitoring within 20, 30 minutes where you're adding the chlorine, your chlorines can be up, they can be down, it's a big mess. So you have to figure for all of this, and you have to understand where that monitoring plan has to focus on. Otherwise, you might feel like you're getting junk data. I'm adding chlorine and my chlorines are going down, and now they're going up, and what's going on. So it's a strange thing to do, to convert chloramines to free chlorine, but we decided to do it. So on the left here was me at some time of night trying to figure out how much chlorine to add, to figure out, there's a bit of thinking involved when you're going through breakpoint chlorination. So there was a bunch of, let's get the old spreadsheets out and figure it all out. That's the easy part. That's the stuff that everything works in Excel. The actual practice was Jamie managed to get support from a local chemical supplier, calling around and said, who can help us here? And we were able to get the support of a local trailer mounted, good to go chlorine skid with metering pumps, and we were able to get an on-site hypochlorite storage and start pumping. So Jamie's guys, this is all very quick. None of this is all happening on the fly. They managed to get down into that valve chamber, figure out how they could actually get the chlorine into that chamber, get these chlorine metering pumps on site, and start dosing the chlorine, and hope that chlorine skid doesn't get washed away in another storm, which we were all kind of keeping an eye on the forecast there, because this was very much still in the thick of it. To the credit, they managed to get everything up and running really well. It was a great collaborative effort. So what does it look like if you take a whole system full of chloramines and you want to convert it to chlorine? I'm going to show you through the magic of stop motion animation here. I remember as a kid, I really liked these old Ray Harryhausen movies where he'd move the models a little bit at a time to create a sort of impression of movement. So we're going to do the same thing here. We're going to take a series of, there was a hydraulic model the city has, and they had a hydraulic modeler consultant on hand, GeoAdvice, do really good work. And they were able to take that model, and we worked together and figured out, let's use the model to help us predict, once we start adding chlorine, how long is this whole thing going to convert? And we're doing two things again with this conversion. Number one, we're converting it to free chlorine so the disinfection is better. But number two, we're also affecting a complete displacement of the volume. The free chlorine is like a tracer. The chloramines don't measure free chlorine. If you go out in a chloramine system, you can't measure free chlorine. Only when you're over to free chlorine disinfectant. So wherever the free chlorine is, if that shows up, you've gotten rid of the chloramines, you've ditched it out of these hydrants we're going to be flushing. So we're converting to disinfectant and we're displacing everything. So we start off with a system full of red here, as it were. And this is the sort of plan, hour by hour. where the hydrants are being flushed. This is where the hydraulic models get really handy. Where do you need to flush? How long do you need to flush? At what flow rates, etc. And so Jamie's crew were able to go out and follow this plan. The timing is not always perfect with the hydraulic model. It kind of depends on the conditions on the day, but it gives you that right sequence of activities to go through and do that. And so the guys were able to do this complete conversion. And by measuring free chlorine everywhere, we knew we've gotten rid of all of the water that was in that system. Everything that's in there has come through that valve. It's new water. So it took about 3 days for the crews to work through and do all of that hydrant flushing and get things converted. And, having converted it, wanted to keep it on free chlorine for a while. And that's so that, even though we've displaced all the water, who knows whether there's any slight residual contamination, biological contamination that is in there. Let's give the chlorine some time to do its work. Chlorine disinfection needs reaction time. The longer you give it, the more it's going to disinfect anything that's there. So as a kind of a belt and braces, just to try and be conservative, they opted to keep that free chlorine in the system for about a week. We're able to do this kind of thing because, we're under evacuation orders, and we could do things like, let's just keep the network disinfected for a week because no one's really using that water right now. So one final thing before I hand things back to Jamie, but the third and penultimate phase was to bring this ring-fenced area of water mains. Now we've got everything to free chlorine. Jamie's guys are still out there this whole time, and they're fixing mains and bringing them on. Well, how do we bring these mains on? Well, there's nice procedures to tell us how to do this, right? So there's AWWA C651. But as we're looking at this, the teams of people who come up with these procedures, they go out to industry and they find case studies and they try and figure out how do we mitigate all the different risks based on what's out there, and they support all of the information you'll find in these procedures is backed up by case study. And you can find that stuff published. These are all the case studies that were used. And we asked ourselves, so these case studies that were used to develop these protocols, were they accounting for this kind of catastrophic event? Or are we falling outside? Are we an outlier here in terms of, the level of risk and contamination? Can we adopt these wholesale, or do we have to go back to the drawing board and make sure that this is the right thing? Or do we have to take any extra effort? We say, how can we know this? You'd have to be an expert specifically in these protocols. Well, we knew that here in Ontario, the ministry in 2020 just completed their disinfection water main procedure. And that was Aziz Ahmed, who's the manager there, who had led that task force. So I called up Aziz and I said, listen, we're working with the city of Abbotsford right now in BC, and we've got this question. Do you have an opinion on that? And right away, he said, listen, I'm going to get together the authors. Let's set up a call. Let's get on the call with the city. We'll give you all of the advice that we can and interpretation of those. We'll run through the procedures and make sure they apply in your case. And we'll give you any technical support you need. So we just received fantastic support. And we were able to go through, and more or less we were able to adopt those wholesale. Couple of minor changes we're allowed to do here and there. But that was terrific support. And again, another nice example of the sort of collaboration we saw around this whole event. Jamie, I'm going to hand things back over to you to wrap things up here.
Yep. So return to normal operation. So all the work that was done in the system, the conversion to free chlorine, we had unidirectional flushing going on, main break repairs, all sorts of things going on at once, but that's all fine and dandy. But in order to get out of boil water advisory or a do not use advisory, you have to have actual test results to show that what you did was effective. So I guess developing our sampling plan, we didn't know, what should we be targeting? As far as dates, I mean, remember this event started, we lost pressure on November 16th. And we're kind of looking at we're 2 weeks in, started December. We've got our minds wrapped around a sampling plan. We knew that Christmas was coming, and although people were on evacuation orders, there was talk of people starting to be allowed back in phases into the prairies. And ultimately, by that last week before Christmas, everybody was off evacuation orders. That doesn't mean they could get back into their houses, but a lot of people were able to, and we wanted to ensure they actually had water coming out of their taps that they could use to at least start the cleanup process. So November 30th, kind of our first sampling run, we decided to do chemical sampling because we thought, there's a good chance we may have had some surface water that entered, but we had no idea what might have entered. So as Simon said earlier, we basically did a source characterization for sampling. We targeted, just like our wells or our surface water, I think it was like 160 plus parameters or something like that. And we did that with the thought that, maybe a pesticide will pop up, maybe a hydrocarbon of some sort will pop up. And then we figured we could use that to target round 2 of chemical sampling to say, okay, everything else is clear except for this one, we're going to target it. Oddly enough, the first round came back and we did not have a trace of anything outside of, those 160 parameters were all within the drinking water quality, Canadian drinking water guidelines. Everything was fine. So our next round of sampling, round 2 came in on the 9th of December. And again, we had everything clear. So from our perspective, we thought, you know what, this is the green light to get out of the do not use or the drinking water advisory, and let's go back to a boil water advisory. Because if you recall, we started off November 18th, we had a boil water advisory on. We switched over to a do not use advisory, I think it was around the 24th, and we kept that thing going right up until December 9th. So drop the drinking water advisory, let's put a boil water advisory on. While this is going on, we know back teas, that was kind of the easier thing. We knew we just had to have 2 rounds of samples back to back that were clear. Interestingly enough, we, like Ontario and probably every place else in North America, we do weekly back tea sampling. So we actually kept up with our sampling, even though the entire prairie and distribution system was under, upwards of 12 feet of water in some spots. If we could get to a sampling spot or a sampling tap, one of our established ones, we would grab samples there. And throughout this whole event, we did not have a single back tea result come back showing a total coliform or anything. They just kept coming back, good sample after good sample. So the back tea wasn't as much of a concern as the chemical was initially, but yeah, it wasn't too difficult to get 2 rounds of back teas. So the 8th and the 15th is when we officially presented our back teas to Fraser Health, our health authority, to say, okay, we think we can get out of the boil water advisory, which was ultimately done on the 20th. So you can see there's a bit of a delay there from the 15th to the 20th, and that was done on purpose. We started with the flip from chloramines to free chlorine, held for 7 days, but then we had to do everything in reverse order. We had to go and flush those hydrants, in the same manner we did the first time, shut off the free chlorine injection and allow the chloramines to naturally come in and flush everything over. So by the 15th, yeah, we had 2 rounds of clear samples, but the issue with that we had is, when you're going through breakpoint chlorination back and forth, you hit your dichloramines and they, you take your kids to a swimming lesson and, whether you're in water operations or not, that smell when you walk into the pool. That's ammonia and free chlorine out of balance. And, well, we all know how the ammonia gets in the pool, but we didn't want to, on the 16th of December, say to people, okay, your water is safe to use now, but it totally reeks of chlorine. And we didn't want that confusion. At this point, people still weren't fully back into their homes. So we decided to complete the flushing. We hadn't wrapped up that last round of flushing until about the 19th. So we had all chloramines back. And at that point we said, okay, let's let this on the 20th. And from that point forward, we've returned to kind of normal operations. We still have some outstanding issues. Those pictures Simon showed you of water mains laying in farmers' fields, those ones have actually had to be replaced. We've got about 1.1 kilometers of water mains that were fully exposed to everything that was floating around in the prairies out there. So kind of an unexpected capital job of 1,100 meters to replace pipe out there. So So that kind of leads us into, some of the conclusions in future planning. And I hinted at it earlier, time and circumstance were on our side. We had lots of time to deal with this, primarily because, there wasn't a lot of pressure on us from a water operations perspective. I also have drainage and dikes under my authority here. So the dikes failing and all that stuff, that's going on, on the other side of my desk. But, operations and the focus everywhere was really on the dikes. We just had to try to get the water distribution system up and running at the same time that people were going into their house. So we were fortunate that we had the time to, sit down, find people to help us, right across the country. The reinstatement plan, as Simon mentioned, nothing, we couldn't really find something to address what we were dealing with. So now this will definitely be used in the future as a go-to plan that we can unbolt and implement when needed. I mentioned probably 8,000 years ago is when the Nooksack started dumping into the Sumas River, and once the glaciers backed out here, and it'll probably go on until the next ice age happens. So there's a chance we will have to implement this plan again. And also being, having the Fraser River to the north, every time we go through the spring freshet, there's dikes on that side too, and there's concerns that we can have flooding on the other farming prairies. So we see use for this in the future. We also need to look at flood proofing some of our critical infrastructure. So by road, ACV, that thing was underwater twice. We had 3, they now call them atmospheric rivers out here. I'm assuming that catchphrase has made it back to Ontario, but that's what they now call these big storms. When I first got here, they called them pineapple expresses. I prefer that. Reminds me of a tropical drink or something instead of some horrible weather event. So anyways, we need to, those sandbags you saw, those were the guys just trying to figure out how are we going to get into this flooded chamber. There was, a good 2 feet of water over top of by valve where the guys had to go in and put that lance in to get the free chlorine in. So we need to do a better job of protecting that and making it readily available. Air release valves as well. There are really no air release valves to the west side, so the flatter area, but when you get into lake bottom, there are because of the changes in some of the elevations. We are looking at potentially putting snorkels on and raising the sort of inlet outlet for those things, but we got to think about it because there was water that got, like I said, 12 to 15 feet up. Like the lake was a lake again, and how high do you build these things? So there's something to think about for that. And finally, let's strategically close some valves prior to flooding. The water did not leave until a month. The lake was there for almost a whole month. So you can imagine staff trying to go around finding main breaks. We had guys out on boats, trying to look for water bubbling up, and can they possibly find the valve? The boat thing didn't work. There was cabbage floating around everywhere and plugged up the jet boat's motor. We certainly tried. If we had some of these valves strategically closed ahead of time, it definitely would have been helpful, and we would have been able to isolate those main breaks earlier and get the system back up and running. So that pretty much wraps everything up. I know there's at least one question. I don't know if I want to hand the Q&A over to our moderator. Maybe I'll just do that. Simon and I will, myself, I'll just kind of close my mouth now and hand it back, and someone can walk us through the questions if they'd like.
Well, thank you very much for a really fascinating presentation. I just imagining what it was like to be dealing with that. I'm sure you didn't get much sleep during that time period. The first question that we have is, can you speak to your ability to get material and equipment during the emergency?
Yeah, so, surprisingly, maybe to some, it was incredibly easy. It actually the difficult part was turning people away. When a flood happens, there's lots of rain and, a few days, everything kind of settles down. It's just some recovery. But for us, we had water on top of us for weeks and weeks. We were unique because we're the only ones who suffered from all this water coming in from the states that flooded us out so poorly or badly, whereas everyone else around us you know, they dealt with it like it was a big storm. It, you know, knocked some stuff out, but it found its way down to whatever outlet it normally finds. So it was incredibly easy. Almost, you know, like I said, the difficult part was turning people away. We had so many calls. You know, I've got this piece of equipment, I've got this expertise, I can do this. We had to actually set up a call-in line just for these people to call in and kind of register. We had so much stuff coming at us. So not hard at all. Very, very easy.
Okay. Yeah, the next question, and I was wondering this as well, could you detail what was contemplated in the event of unfavorable chemical and BAC-T results? Because you looked like you, as you said, you were surprised at the quality when you went to do the measuring.
Yeah, I can add some preliminary comments, and Jamie, you can add anything you'd like on top. I mean, the chemical would have been the tougher of the two in terms of knowing which direction that would go in. In the case of biological, you kind of know what's happened, right? You've had an ingress event, you've caught an indicator, and so you've got a bacteriological or potentially viral issue to deal with. Well, with enough contact time and enough free chlorine and enough flushing, you're going to manage that challenge. If you really had to, you could be just aggressively UDFing or swabbing. There are tools available there. So had it been bacteriological, I think that's something that could have been dealt with fairly routinely. Had it been chemical, it really would have depended on the nature of the chemical event. I think the one that we were all most worried about was some kind of gasoline or diesel fractions. Those stick around. And when they're chlorinated, they form chlorophenolics, which have, you know, a really, really distinct and obvious taste and odor. And I dealt with chlorophenolics in a distribution system before, and they just linger. And, you know, they're naturally sticky, and they stick around in little pockets all over the system, and you're into a real challenge to try and systematically remove those. Anything else that had been sort of more bulk in nature, like pesticide, etc., I think it would have been more like again, we could have relied on flushing just to displace those volumes. We knew we'd affected a complete displacement in the volume, so anything remaining ought to really have just been anything that was trace on the pipe walls. But yeah, that was the big concern. We were really worried that something showed up chemically. But the course of action would have been in dialogue with Fraser Health. We'd have said, this is the situation. This water is non-potable until we get this back under control. And we'd have workshopped it and made a plan and executed the plan, you know, to get it back under control. But we were fortunate. We were fortunate because you're right, that could have been a real can of worms.
Yeah, I have no further comment. That's perfect.
And there's one more question here, is how did you protect users during the chlorination process and then bring the users back safely online? So I think that might have been tied to when you were in the middle of the evacuation, you were doing the chlorination. How were you making sure that nobody was accessing that water and then bringing it safely online?
Yeah,
Jamie?
I guess I could, you know, the protection for that was public advisories, you know, as far as whether it was a do not use advisory or a boil water advisory, whatever we couldn't kind of cross off to say, yeah, we don't think this is a threat based on sample results. People should use or not use the water in a certain manner. As far as protecting people, maybe I'll pass it back to Simon. Like, this is our first time doing a flip from chloramines to free. And, you know, we did have some concerns, like, you know, what's going to happen to this event? What's the water quality going to be like? So Simon, just to say, you know what? It wasn't really a big deal. We weren't overdosing on this and that sort of thing. Anyways,
Yeah.
Simon, if you have thoughts.
Yeah, I'd only say that, you know, the only change that the conversion disinfectant has really relates to that sort of a curve, that every liter, every parcel of water that passed through that valve and that was chlorinated went through. Every single parcel of water went through, and in the process, when you get to that high point and you're just coming down, where you flip over to free chlorine, right there, you know, you're going from a mixture of ammonia and chlorine to lots of chlorine, a little bit of ammonia, and then finally, you know, you oxidize off and breakpoint that ammonia over to chlorine. That middle bit there is a nasty fraction. only because it creates, as Jamie alluded to, lots of this stuff called dichloramine, which is a really strong swimming pool smell. But there's no real health concerns around that piece. It can be unpleasant. It can smell. If you're doing it in a regular system that's live, you're going to be wanting to make sure that residents don't get suddenly concerned and start to question what's going on. Why does my water smell like this? So when it's a live system, you got to put out a bit more messaging around that. But in our case, as Jamie said, we had advisories on, people shouldn't be using that. And even if they had done, the conversion process itself doesn't present any public health risk. As soon as we're over to free chlorine, we're actually mitigating that public health risk.
That's great. I think that's the last of the questions. I'm going to pass it back to Ian at this point to finish up our AGM. Thank you again for a great presentation.
It's nice of you to have me.
Cool. Well, thanks to
Yeah, thank
everybody,
you.
and
Appreciate that.
thanks for sharing your time and sharing your experience. I'd like to thank first of all Norman Shippey, Ryan Monez, Jamie Austin, and Simon Horsley. Your presentations were awesome. And geez, Jamie, Simon, I think you guys have to talk to Norm, because somewhere along the lines you guys are crossing paths here, or should be crossing paths. To the four presenters, I'd like to, as a token of appreciation, say that we'll be making a donation to the Ottawa Food Bank on your behalf, and thank you again for that. I would like to thank all of the participants for coming in today. Especially, I'd like to thank the executive, our new executive, Susan Liver, Barb St. Aubin, Megan McSween, Jason Betez, and Arup Mukherjee as this year's executive. Our directors coming back: Sandra Mancini, Jamie McDonald, Andrew Murray, Amanda Shane, Andre Bork, Brigitte Altingmies, and Rob Gibb. Thanks for all of your work so far in previous years, and all you're going to do this year. I'd like to also thank Connell Cosgrove and Hiram for coming in and for joining our team and just being part of this. And then finally, Brian from the chapter, Don Kudo, the president of the Ontario chapter, and Brian Barber, who nobody saw because everything worked perfectly. Brian Barber put together the whole Zoom presentation for today. So thank you, Brian, for putting this together. If there's any further thoughts, questions, comments, please feel free to contact us at our email or through our LinkedIn account. And we have our website as well. And we're going to try to get these presentations put up on our website. So on behalf of the Ottawa Valley branch of the Ontario Public Works Association, thank you to everybody for coming in today. And thank you again for everybody for your presentations. Have a great day.